Hello, everyone. Homer White back again with a final screencast for section 2.1 on examining numerical data. This time we have just one topic to cover: how to study the relationship between two numerical variables. Now, much of this has been alluded to before when we first started looking at scatterplots. But now we're also going to get into the R code that you need to make scatterplots on your own. So we want to learn about a new data set. It's called swim records, and it lives inside a package called mosaic data, which you will probably not have attached to your R session up to this point. So you're going to want to run this command, library mosaic data, as well as the usual view and help on the data set inside the package that you'd like to see. Let's go ahead and do this in RStudio. There we go. So it's a pretty simple data set. Every row is the event of a world record being set in the 100-meter swim. And the information given about each world record event is what year that world record was set, the time it took to finish the 100 meters, so what the record actually was, and that's in seconds. And also the sex of the person who set that record, M for male, F for female. Again, you just want to keep a mind out for classifying variables. And so, like, what would you say is the year variable? Numerical, I suppose you could say numerical discrete, because there is a smallest possible difference between two calendar years, 1. Time would be numerical continuous. Two swim times could be a second apart, a tenth of a second apart, 100th of a second apart, no smallest possible difference. And sex I would call categorical nominal. Nominal, not ordinal, because there's no natural ordering between male and female. Again, the help is very useful to verify things like the units on things, so time in seconds for the world record. You can see right there. Okay. Let's think back on what we would like to do with this data. We'd like to see how have 100-meter swimming records varied over the years. So this is a research question that involves two of the variables from the data set: what year it was and what time it took to complete the 100 meters for that record. So I tend to think this time that year helps to cause how long it takes to complete, because swimmers get better over time, especially world record swimmers. Their time has to go down in order to actually set the record. So I think of year as explaining time. Year shall be the explanatory variable, time shall be the response variable. Now when we, just another slide on the types of variables, when we study two numerical variables, then we do want to look at a scatter plot. And here is a scatter plot for those swim records. Every dot on that scatter plot stands for a row in that data set, a particular world record event. And it's a strong convention in making scatter plots that if you've got an explanatory variable in mind, you should put that one on the x-axis, here, horizontally. And the response variable will go on the y-axis, vertically. So for this particular world record, it was set in the year here down on the x-axis, which happens to be 1905. And it was more than 90 seconds that it took for the person to complete the 100 meters. And same for all the other points. You might wonder why there appear to be two clouds of decreasing points, an upper one and a lower one, until you realize that both men and women world records are included in this data set. The men are probably the faster ones down here. And notice how the women kind of caught up rather quickly, but it looks like they've kind of stopped catching up in recent decades. So how do you make a scatter plot with R? Well, the format is very similar to the other R functions that we've learned so far. It's just that your goal is different. Your goal is a scatter plot now. And so you're going to use a function called gf_point, reminding you of the points in the scatter plot. And then, inside the parentheses, you've got to talk about the variables that help to make the plot, the data set where the variables live, and other optional things to make the plot look and work better. The first input there, time twiddles year, involves the two variables. The way you'll always work it is the response variable comes first, and the explanatory variable comes second after the little twiddles. Remember, the twiddles tells R there's a formula involving variables, and when you have the response on one side and the explanatory on the other, it knows which axes to put things on. A nice way to remember this, that response, twiddles, explanatory, is that the response comes first, and when you look at a scatter plot, that's the first thing you'll see as you read from left to right. You'll see that response variable on the y-axis. Data is swim records, that's where the variables live, and you want to label the axes. And you can label an x-axis with xlab and a y-axis with ylab. Make sure you put your labels here inside of these quotes at the beginning and the end. As always, separate your inputs with commas. You do not need a comma after the last input. And when you use a function, you always start with an open parenthesis, end with a closed parenthesis. So this ought to work. Let's give it a try. Copied and pasted, running. I see it in the plot window here. I will click to look at it big, and it's what I expected to see. Okay. Now you might be curious, is there a way to tell the user who are the men and the women? You know, which points go with a male record and which points go with a female record? You could do that if you could somehow associate the color of the point with the sex of the record setter. Is there a way to do this? Here, I'll just show you. It's not something that you have to memorize and just be able to use all of a sudden. But it's fun to see how these things work. And after a while, you can start to consult online resources for this particular graphing package and make fancy plots yourself. So you can make a new file here. Under File, I'm going to make a new file. And I'm going to make it be an R script, which is just a quick way to hold some R code. I'm going to immediately say Save As. And in my home directory, I'll go to My Notes. And how about, I don't know, fancy scatterplots.r. Always use a .r at the end when you're making an R script. Save. And then you can actually make some comments for yourself. if you have one or more hashtags at the beginning of a line, I always like to make 2, but 1 is fine. Then you make a comment, and that's not our code, it's just a message for you to read and remember what you did. Swim records, color by sex. And then you can write in that you needed that mosaic data package. And then you can write in GF_point. And I will enter here, so I'm on a new line. And I will say time twiddles year, and data equals swim records. There it is in the code completion, comma, and color equals. And what we want to do is we want to map it to the sex of the person. Now, how is sex spelled? Let's go over here. In the view, it's sex all lowercase. So it's a variable, though, and you need to tell R that this is a variable in the data set. So you go twiddles sex. You could also make X and Y axes, but I think I'm just going to see if this works to color the points. And so what I'll do is with my cursor at the end of the command, I will press, you can press Control-Enter or Command-Enter on a Mac, and it'll run. Or you could press Run right here as a button. If you want to be sure exactly what you're running, you could select and press Run. But I think it's easiest to just go right to the end of your command and Control-Enter, it runs. Thinks about it for a bit, and I'm going to zoom it up. And sure enough, it's colored the sexes differently, and it's provided a little legend on the side for you to figure out who's a male record setter and a female record setter. So that's just a fun experiment with Scatterplots. I'll save my results here. And whenever I want, I can close that file by clicking on the little X. I won't close it right away, though. Let's see what we have next. So here's the basic template for GF point. As I've explained before, response variable comes first, then the twiddles, then your explanatory variable. The data is always whatever data set you're working with. The XLab, optional but important and you have to put that nice label, that's not an actual label, that's just like an example of what you might say, inside of quotes here at the beginning and the end. Same for YLab. That's the basic GF point form for Scatterplots. Want to review terminology for describing associations, relationships between two numerical variables. So we've seen this before, but let's say it again. If you make a scatter plot and the cloud of points rises to the right, that means big values on the x-axis are associated with bigger values on the y-axis. Small values on the x-axis are associated with small values on the y-axis. So here, the taller a father is, the taller his son is likely to be. Every point here is a father-son pair. It's not a single person, it's a pair of people. X-axis father's height, y-axis son height. Here's an example of a negative linear relationship. So it's linear because the cloud of points follows the line, negative because that line is going down as you go to the right. It's fake data, just variable x and variable y here. Negative linear relationship. Big X's go with small y's this time. Sometimes you get perfectly good relationships, associations between numerical variables, but they're not linear ones. So like here, in this fake data, when X is kind of small, y is kind of big. When x is in the middle, y is kind of small. And when x is big, y is getting big again. And so the result, putting it all together, is a curve. So you don't say it's positive and negative linear. That doesn't make any sense. Just say it's curvilinear, follows some kind of curve. You don't have to have a complete cup. You can have anything that departs from a line for your pattern. Here is a curvilinear relationship where the curve is always going down, but it's just leveling off a bit. And this is real data where every dot is a utility bill for a certain house up in Michigan, I think. And the house was followed for many, many years, so there's lots and lots of utility bills, one every month. And on the x-axis is the average temperature outside that month, and on the y-axis is the gas bill in dollars. And so it kind of makes sense in a place like Michigan. When the temperature is low, you're running your heat a lot, so you get high bills. When the temperature is higher, you're not running your heat, and the bills are very low. And there's no air conditioner really needed at temperatures like 60 up to maybe 80. A lot of houses in Michigan didn't have air conditioner anyway for that reason. But I imagine if you did have higher temperatures, 90, 100, and so on, you'd be looking at data where the house has air conditioning, and you would find the utility bill rising again at those higher temperatures. But that's just not part of this relationship here. And of course, if you see a random cloud of points with no rise or fall, as you read from left to right, then there's no association between your x and your y variable, no relationship. So that's it for section 2.1. I probably will have a little screencast to just sort of get us a little bit of the way into DA for 2.1, learning about the data and thinking about how we might fill in answers to a couple of the questions. That's all for now, though. Bye-bye.